So the x-axis is gigaton removal potential.
Hmm.
So many people at some point in the last 5 years got excited about carbon removal. That's
Yeah.
good. It's important.
Yeah.
And that was me for a portion of 2020. Inarguable science that, like, in some ways it's too late. We not need to just abate emissions, but we also got to suck it back out of the atmosphere.
Yeah.
So thankfully, scientists have been toiling, largely in obscurity, at least obscurity relative to my awareness, for a long time to stack rank each of these different technologies.
Hmm.
And I have no interest ultimately in the, like, this carbon removal versus that carbon removal debate. Nonetheless, like, yeah, you got to, like, evaluate options. And so this plot has the x-axis is gigaton removal potential, the y-axis is cost.
Hmm.
And we want things, yes, class, in the bottom right. We
Yeah.
want a lot of tons and we want them cheap. That's
Yeah.
the point, right? Um, these technologies all have pros and cons. Again, this is one plot. Never make like a major life decision on one graph the way I have. But the box in the bottom right-hand corner is called soil carbon.
So we basically have like a science and a cost, which ultimately equals like an accessibility problem here, to put it
Mhm.
shortly, right?
Yep. So two ways to oversimplify, as all things are. The first is that our equipment can move faster. Now, people who work at Yardstick on our field team often disagree on this because they are the best damn conventional soil samplers in the world.
Yeah.
So the problem is, in order to train our technology, we have had to get amazing at conventional sampling as well. We
Hmm.
teach our probe to quantify organic carbon by teaching it on training data that we collect in the
Right.
exact same spot, conventional.
Interesting. Mm-hmm.
And so many of the efficiency gains that our company has achieved in conventional sampling actually makes our cost competitiveness against ourselves like pretty limited. But that is pretty uniquely, in my experience, the domain of Yardstick. Is we are incredible at conventional sampling and incredible at spectroscopy. But that's cost advantage number one. If
Mm-hmm.
you took a typical soil sampler out to the field and compared the amount of time that they spend in field conventionally versus spectral, we would have the advantage.
Hmm.
And this makes a lot more sense when you look at a video of our instrument in action, which I can send you and we can put in the show notes.
Yeah.
The second, which is more important, is the elimination of laboratory analysis. So while we concede that to directly quantify OC stocks, yes, you do need to be in the field, uh, our technology trains a spectral instrument. And so, again, you'll see in the video, when you collect data with our instrument, you're not taking anything out of the ground. You are effectively taking a movie of the soil profile for 45 seconds or so, and then you're moving on to the next sample site. This is also why I mentioned previously, while I, of course, always want labs to be more efficient as they can be, I think fundamentally, unless we're eliminating the physical soil sampling itself, we're unlikely to see the magnitude of cost reduction that we need to really scale these technologies.
Yeah.
So they're sort of in reverse order of importance, but we go faster in field. Therefore, the cost of a person's labor is amortized around across a larger number of sample sites. Therefore, each one is cheaper. And we eliminate the lab analysis portion of the puzzle after we've trained our instrument.